All right, well, today we're going to be talking a bit about how we're expanding the evolution of AI and software testing and how we're applying AI in our own tools, both from the perspective of what we have in our tools today, as well as research that we've been recently doing with the rise of all the advances in generative AI, and such as ChatGPT. All right, so just as a quick overview, at Parasoft, we have our continuous quality platform that spans all aspects of the software development lifecycle, starting with our language tools that do static analysis and unit testing at the code level. We have our functional testing products, many of which you guys have heard about. Different customers talk about how they use those today. So test and virtualize for testing APIs and virtualizing APIs. We have Selenic for doing UI testing and stabilizing UI testing with Selenium, and many more. Our continuous quality platform is an open platform. It's one where we can integrate with lots of different third-party systems that you might be using in your organization. It's an actionable system, so it presents results to you in a way that you can use and act on. And it's an intelligent system. And so what you'll see today that we're going to be discussing is how it has AI infused at all the different layers of the platform. So what we've been focusing on recently, as far as AI and ML and testing, we have technology that helps us create more intelligent tests more efficiently for users. Technology that helps us self-heal tests as they execute, helps us maintain the tests. We have technology that helps us select which tests we should run. So when changes are made to the application, which tests, we optimize the tests that need to be run in order to get quick feedback into the development lifecycle, help us assess business risk, and many things like that.
We're going to talk about AI and machine learning from the perspective of testing and automations. And of course, today we will not be able to cover all different technologies we have. So our primary focus will be on static analysis, it will be on unit test generations, executions, and it will be in area of functional test, end-to-end testing. And specifically from perspective of what we already have inside our tools from AI perspective, and the most interesting what's coming to us from generative AI perspective, right? And Diego spent a lot of time about this in his early presentation. So we will share with you where we're going with this and how potentially we can improve offerings and give more to our customers from that perspective. So static analysis, obviously the foundation of the quality, and I think if you can, yeah, it's foundation of the quality. It's the most straightforward way, obviously, to detect common problems without even code executions. Just run static analysis. It will show you most of the problems related to some violation of rules, specific security standards. It's a good technique to enforce good practices from development point of view. Generally, it's a way to detect the problems and prevent them from happening from the source perspective. The bigger problem actually becomes when software development organizations enable those rules and in the middle of their project development, or even worse, at the end, and now they have thousands of violations and they might become overwhelmed. How are they going to fix it, right? Which of those problems they need to start with first? And to help them from that perspective, that's where we built several AI-based technologies, which we combine in one workflow. And we will start with classifications of those violations, looking in the history and learning from the past, which violations were considered to be critical to be fixed and which of them were suppressed. We can filter out and cluster those violations in the future to basically suggest which of those new need to be addressed in the first turn, right? And maybe release the priority, remove the priority for others, and maybe customers can suppress them in the future. Then we look into what we call detection of hotspots. hotspots may be associated one line of the code, which create hundreds of violations across your code base, because in one place you initialize the object in the wrong way, and then everywhere you're using, you'll have the problems. Showing those hotspots allows the developers to fix the violations first and address majority of them from one single line of code, for example, right? So it's optimizations of the performance of the developers. And then another techniques, again, based on learning, we associate developers' skills with the violations which they fix. So we kind of learn and create profile for every developer. In the future, when new violation comes, we can match to what we learned from the past, and we can automatically suggest who is from the development teams will be the most suitable to fix particular violation, particular problem. So all this together, combining all the workflows, we help our developers to optimize their performance while fixing the most important violations. Those solutions we have today. Now, with all generative AI coming into the place, of course, we've been very excited and look into this technology and see what can we do to improve and use advantage of this technology, right? So we start looking at the ChatGPT. I actually, from ChatGPT perspective, I generate this slide asking ChatGPT to describe itself, how it works, and it came with this wonderful slide. It's basically generative models, as you're aware about that. It's trained on huge amount of data, but it understands nuances of their language, human language, right? And it's kind of understand association between the object, between the things. So it's not just simple language modeling. It has a knowledge and semantic knowledge of what it's actually talking about. It has different techniques to optimize performance of the model itself. The most interesting, what I want to mention now, it's prompting, right? So prompt is kind of input to generate your test-based responses from the system. Prompt allows to create the context into which you want to receive answer from the system. And using different prompt engineering technique, you can kind of guide your generative AI to give you more precise answer on what you're looking for. The reason why I'm emphasizing on prompting, because that's what we're trying to use, and Nathan just actually will take from here and show you some examples of how this properly structured prompt engineering can help to get interesting value from generative AI systems, specifically from ChatGPT.
Great, thanks, Igor. So I'm going to talk about two things related to static analysis and generative AI. As I mentioned previously, Parasoft we have static analysis tools, and they're very good tools. They help identify issues in the code. But one of the key problems with any static analysis tool is when a violation gets reported, a developer has to look at it and decide whether it's a real violation or whether it could be a false positive, or maybe it's not a false positive, but maybe it's a violation that has a valid reason that they don't want to fix it. So in that case, maybe they would suppress it. The second thing is then developers have to actually fix the issues once they decide that it's a real violation that they need to address. So we've been doing some research on how we could apply generative AI to these two problems. And one thing that we're thinking about is how could we, when a violation gets reported by our tool, how can we give the developer additional context and information about the violation and their code to help them make a decision about whether or not they should fix it. And then the second is, generative AI, we find, can write code. So could we actually use the generative AI to create a valid fix for a static analysis violation? If we could do this, it'd be really cool, right? Could we, in addition to having the tools generate violations and tell you where there's potential problems, could we also have it tell you, hey, here's a potential fix, review it, and hopefully it's good enough and you can apply it to your code. So I'm going to talk about some research we've done with ChatGPT around these two issues. So let's take a static analysis violation as an example. We have a rule that for security reasons, says that all exceptions in your code need to be either logged or rethrown. And let's take a code fragment that violates this rule. So we have a catch that doesn't print or log it or rethrow it. So we did an experiment where we said, well, can we create a ChatGPT prompt where we give it the rule documentation? This is documentation that our tools already have that we use to, users can use to explain a rule and how to fix it. Generally, it provides a description, it provides an example of a violation of the rule, and then an example of how you would fix that, and other links and so on to other information. And then we obviously have a code fragment that the rule might have fired on with one of our tools. So we created a ChatGPT prompt, and as Igor said, the prompting takes some refining. It seems like it's a little bit of an art to actually get a prompt that gives you something interesting and useful. But we came up with this prompt that says, okay, given some code, and we give it the code, does it violate this specific rule? And we had also fed it the rule description. So I'm not showing you those prompts, but assuming that information was given to it, we asked it to provide a response answering, does the code violate the rule? And we asked it to give it in a specific format with an explanation, some specific points, like why the code does or does not violate the rule, and any additional comments. And what do you know? It came up with something very interesting. You can see that it has a brief explanation of what the rule does. Okay, it's pretty easy probably for it to figure that out based on our description. But then it has some reasoning specifically about analyzing the code, plus the information about the rule, and accurate description of why it is a valid violation. But then again, at the bottom, it actually explains a reason why maybe you don't need to fix it. So it's giving context to the developer. These are the kinds of things you should think about before you go ahead and fix it, right? And so you can imagine, like, if we could present this information along with the violations of our rules, how this could give a lot more information to a developer about how to fix the rule or fix the violation. So this is one example where we're really excited. We think there's a lot of potential. We could continue to refine this to present some information that would be really interesting for users. So let's switch to the second case now. Let's assume that another case where I have a static analysis violation, but I want to generate a code fix for that violation. On the screen, I'm showing an example of a violation in C++ code that where a variable, a string is supposed to be null terminated, and the rule detected a case where it's not. I'm not going to go through this, it's kind of complicated, but the key points are it goes through 4 different files, and if you look at the trace here, you'll see those 4 different files. So this is what we would call a flow analysis violation. So the stack analysis engine is analyzing the flow through the code, and it had identified this issue. And it's a real issue in the particular code that it analyzed. So we started experimenting with ChatGPT to say, well, can ChatGPT generate us a code fix for this rule? And much like with the stack analysis case, we had to iterate a few times until we could get it to provide something that was useful. So one thing that we did is we provided it with the source code. So I told you that the flow trace went through 4 different files. So we actually provided it the source code for each of those 4 files. Secondly, we have the rule documentation that's already in our tools. So we then provided it the rule documentation for the specific rule that got flagged in this code, specifically about strings need to be null terminated. And then we gave it information saying, we have a violation, please try to fix it. The first time we did this, we actually gave it a little bit less information than you see here. At first, we just said, here's the violation, please fix it. And it gave us some kind of general info. It was generally correct, but it wasn't as specific as we wanted. When we refined the prompt to say that the cause of the bug started in the first file in the flow trace, it all of a sudden came up with something much more specific and much more interesting. So again, this is a case where refining the prompts is an art. You have to figure out what it needs to know to provide useful information. And in this case, it provided a suggested code fix. Again, I'm not going to go through this in the interest of time, not too detailed at least, but it pointed out a specific line that needed to be changed. It told us how, when we initialize the variable, we need to initialize it as a null terminated string. And then when we copy data into that variable, it also needs to be, you need to make sure that it's null terminated. This is actually correct code. These fixes would fix the static analysis violation. So you could see we probably need to refine the prompt a little more to so that our tools could actually pull out the information, in an automated way, a programmatic way, and then actually apply it to the code and generate a fix. But you can see how this kind of technology, sort of combining what we already know, the technology and the expertise that we have at Parasoft as far as analyzing code, identifying violations, understanding what the code's supposed to do, with the power of ChatGPT that knows how to sort of synthesize all that information and generate code, it actually produces something that could be very useful for our users in terms of helping them more efficiently fix their code. So that's what I wanted to share about static analysis. Next, we're going to shift to now talking about what we're doing in the space of unit testing. So Igor, you can jump back in.
Thanks, Nathan. Unit testing obviously is the next most popular testing techniques. It helps to validate functionality of your code. And in general, it actually helps to design better code if you follow unit test practices. It's identify regressions, problems, trying to catch any issues which you might introduce to your product as you continue doing development, or enable you actually do refactoring with much higher confidence. From our perspective, we have capabilities to automatically generate the unit test for our developers. And so whether you actually trying to cover specific line of code in your methods, or you probably want to mutate your test to extend the coverage boundaries of what you're testing, or maybe you just want to generate hundreds of tests at once for your entire legacy code, right? Our models technology, what it does first, it's understand the sources. So we build these models, sophisticated models, which build the knowledge about your sources. And then using flow analysis engine, we basically discover all possible execution paths through your code without actually running the code, right? And we call them recipes. And once we go through each potential path, it's kind of semantic kind of executions, virtual execution, right, internally. We calculate the complexity of the code, whether we can create the mocks associated with that particular path, what the coverage you'll get, and we have these heuristics inside which basically assign the scores. And then depending on strategy of your unit test creations, maybe you want to create a test to maximize the coverage, or maybe your objectives is create the most simplistic test because they have tendency to be more reliable, right? We will pick up the right paths or recipes. We will basically resolve all their variables inside them to understand how we need to initialize the sources of the methods under the test, how we need to initialize the mocks. We'll automatically generate the test with all those input parameters. We'll run them in background to auto-generate assertions. So this allows us to build entire set of tests with high precisions, good quality, and to increase the coverage of your sources from test perspective. Now, our focus is not only create as many tests as we can. We want to be smart about that, because the more tests you'll create, the more maintenance problems you may create in the future. Every time you change your code to do refactoring, you'll have to go back and modify a lot of your tests. So we use the techniques of test optimizations using the coverage informations. We will remove duplicated tests. Basically, we'll try to keep only those tests which matter the most for your goals. So combine all this together, we're trying to address the problem of maintenance by eliminating redundant tests. And again, when generative AI comes in place, we start thinking how we can extend capabilities of what we are already doing, combine this with deep semantic understanding of generative AI, and figure it out, can we do better? Can we generate better tests? And that's where Nathan actually did a lot of interesting experimentation to share with you right now.
Excellent. So just for the example today, I'm going to look at a very simple method that I might want to unit test. And again, as we did for static analysis, I'm going to explore, and in our research, we're exploring how we can combine the best of what Parasoft already knows how to do in our unit test generation with additional benefits that we could get from generative AI like ChatGPT. So for the example I'm going to look at today, it's just a simple method that calculates a Fibonacci number. Fibonacci numbers are the ones where it sums up this next number in the sequence is the sum of the previous two, right? So it's a very simple method, not a lot to it. If I were to create tests for this using our Parasoft JTest, our unit test assistant, it would give me these two tests. You'll notice about these tests that they have a very consistent format. They cover two cases, so you'll see an input with of 0 and an input of 2. Our engine determined that we needed those two values in order to ensure that all branches in the code were handled. And so, as Igor mentioned, it's optimized. It's optimizing for coverage, but with a minimal set of test cases to get the highest coverage. You also notice that we have assertions, and the tests, these are correct tests and they cover the code. Now I used a very simple prompt and prompted ChatGPT and just asked it, please generate me tests for this code. And I did it a number of times. And so here's two of the examples of what it gave me. You'll see in the first case, it initializes the class, it's a simple class, and then it creates a bunch of different assertions with a bunch of different inputs for the first, I guess if you count 0 as an input, the first 7 Fibonacci numbers. And all these assertions are actually in fact correct. So one thing that you'll notice is that it seems to semantically understand what a Fibonacci sequence is, understands what the values are, and so it was able to generate valid assertions and valid inputs, right, that go together. If you look at my second example, it actually does the same thing. One thing you'll notice is the format of the test case is completely different. It uses a for loop instead of a list of assertions, although then it decided to add a few assertions that it called edge cases, and some of them are repeated. So one of the things you'll notice, and I know Diego mentioned this earlier, it is a generative model, and so every time you give it, you prompt it, it'll respond to something different. There are parameters that you can use to adjust that, but in general, you get something different. And you can see how, if you wanted a tool that you could use in your development to generate unit tests, you probably would want a more consistent format. So this is a downside. The upside is it seems to understand semantics of the code. This method and class aren't super interesting, but another thing that we noticed in other cases that we've tested is that the names that it gave the method often were very accurate to what that specific test case was testing. So it generates really nice names for the methods in many cases. And it's able to come up with a lot of interesting inputs. So what we were thinking about is, okay, I mean, the Parasoft test cases are good. They miss some of the semantic information. So could we somehow take some of these, the understanding that ChatGPT has about the semantics, but combine that with what Parasoft knows about specific values to cover the code and optimizing the test cases. So we had to work at this a bit. The prompts, again, for ChatGPT, we had to evolve over time. We came up with a pretty complicated prompt. One thing I should mention before I go into this, there's one other aspect where ChatGPT made some mistakes. Most of the time it was good with generating assertions. So the cases I showed you, these assertions are all correct. But there were some cases where the assertions were incorrect. I would say, I mean, ChatGPT 4 is better than 3.5 in our observations, but we still found cases where it's incorrect. So obviously you want your test cases to have correct assertions. We know that our engine, because it's running the code to generate the assertions are always correct. So that's another thing that we wanted to leverage from what Parasoft is already good at. So we created a prompt where we gave it a very specific format that we wanted the test cases to be generated in. And you'll notice this format is much closer to how Parasoft JTest already does it. We specifically instructed it not to create assertions because it always wanted to, which is generally correct. A unit test should have assertions. But we wanted it to generate in a format that we could then run the test and generate the assertions ourselves. And we also wanted to provide it with some inputs that our engine had determined, hey, we have to at least use these inputs to cover the code. But then we wanted to ask it for additional inputs that maybe it would understand because of its understanding of the code semantics that might be more interesting to add in addition. So with that prompt, then we asked it, please generate unit tests for this code. And you'll notice that we're giving it the code and we're giving it a couple of the inputs determined by our flow analysis engine. And when we did that, you'll notice now all of a sudden the test cases are much more, the format is very consistent now. It's using the exact values I asked it to. The test cases are set up in a format that we could then easily add our assertions to, and in an automated way with Parasoft JTest. The names, not super interesting, just because I think this test case, the values, it's hard to describe the values in an interesting way. But in other, as I mentioned, in other cases, we saw some really descriptive names for the test cases. All right, so this is good, but you'll see this is only the values that our engine already determined. So then we asked it, well, are there additional inputs that you could use to generate additional tests to cover more cases? And obviously the code from all the branches of the code were covered, but we're thinking here more about the semantic test cases, right? Different things we might want to test. And at first gave back just an interesting description. This is, if you read this closely, it actually got some things wrong. It says it didn't prevent negative inputs. So this is its hallucination that Diego talked about. This can happen. The code did prevent it, although I would argue that providing a negative input is still an interesting value, because what if somebody refactors the code in the future and then forgets about that case, right? So having that is not actually a bad value. And you'll notice it suggested some other values. I then needed to prompt it and say, well, can you now combine these inputs with the previous test cases? And then it presented me with a set of test cases that included our original test cases plus the new inputs that it suggested. So this shows some example of how we might be able to leverage our two technologies together. So when we looked at we observed sort of what each technology was good at. As I already mentioned, ChatGPT generally has greater conceptual understanding of the code just because it's been trained on so much code. It has a very high variability in the tests it generates. It also, in some cases, the code doesn't compile, or it might have some errors, give variable name, or try to access variables in the code that don't exist. Because of token limits, sometimes it just stops generating tests if you're generating for a very large class. And we found some cases where, because it was trained on data that's about 1.5 years old now, for trends that have changed in the industry and best practices that have trained, it doesn't necessarily know the new ways of doing it. On the flip side, if we look at what Parasoft is good at, our test cases generally have greater consistency and greater quality, but the test cases were a little more generic, right? They didn't understand the semantics as well. They're optimized to cover all branches of the code. ChatGPT is generally slow. If you've tried it, you'll see if you give it a lot of input and it needs to generate a lot of input, it's slow. Our technology is optimized for creating many tests all at once, analyzing a large set of code. And there's a lot of concerns about, well, what happens when we, are we exposing code to the internet, to ChatGPT, that we don't really want to, right? Whereas, so in Parasoft, we work on prem, right? We don't expose your code to the internet. So if we look at all of these things together, what we're exploring and we're excited to look at for the future is, how can we take, the strengths of Parasoft JTest and how it generates test cases, but use the ChatGPT generative AI to incorporate additional use cases that might be interesting to cover, better names for the methods, and actually create better semantically aware tests that combine all the benefits of good code coverage, the output's very consistent, and all the assertions are correct. Another thing that we're working on is, how cool would it be as a developer's working on code and they're making changes? In the background, the technology is analyzing the code changes and automatically generating tests for the code that was changed, right? So when they're done working on their code, they have a set of unit tests that test the code, all their assertions are correct, and they just need to review. That would be pretty cool. So that's something that we're researching and working on, and hope to incorporate into our tools very soon. And next, we want to switch to API testing and what we're working on there.
Yeah, so API testing is definitely another favorable techniques to test, specifically to perform end-to-end testing, right? Or run your functional test. It's preferred compared to UI just because it runs much faster. It gives you feedback. It's more stable. We know that UI test has problems with stability. And another interesting side effect, once you create your API test, you can reuse them, for example, for load test performance testing and for penetration testing. And our tools allow to do that. And on top of that, service virtualization technology works really well with API testing to decouple your applications under the test from any external dependency. So you can run your functional test without being in concern that some external systems might not be available to you, or when you want to simulate behavior of the system in a specific way. The key aspect of our existing technology is Parasoft Self-Test Smart API Test Generator. So what it does, it helps their developers or QA engineers to convert web-based UI test into API test. So for that purpose, for example, we have this browser-based plugin which runs inside your Chrome as a recorder. It captures all the user actions during manual test executions, but at the same time, it captures the traffic of communication between the browser and your backend systems. Now, UI has all the knowledge about the business logic. Whomever create your web UI layer, it's already built-in logic which knows how to connect the APIs, how to call them, which sequence, and which parameter to pass. That's the challenge which we're trying to help the developers or QA testers to address. We capture the traffic, and then we build a model which basically understands what this traffic is about, what the business logic is implemented through this traffic. We understand which parameters pass to the backend system, what the payload is returns, how they can relate to each other. We can do parameterizations, and based on this model, we can automatically generate those UI API tests, which completely independent now from your UI. It basically re-implement all the business logic which you presented by your services, and this model can be enhanced. The more often you use, the more traffic you kind of throw into our technology, we learn more, and then we can reuse it to build even more advanced test cases from an API perspective. But there's certain limitations which we have with this, because we kind of tied ourselves mostly to the examples which comes through the traffic, whether we capture traffic from UI through this recorder, or we capture traffic through any proxies maybe in communication between microservices. That's where we start looking into the ChatGPT technology, again, in generative AI, and figure it out, can we extend those boundaries, go beyond of what actually been captured and represented by the traffic? that's where Nathan can show us some interesting thoughts on this topic.
Great. So yeah, when we have the traffic's awesome, and the Smart API test generator is great at analyzing the traffic, extracting the flows, which parameters need to get passed from a response to a subsequent request in order to create an API scenario that actually tests a real flow. The limitation is that we actually have to have traffic for all the flows. So imagine if you wanted to test for different kinds of error conditions, right? Or different kinds of security scenarios. Without some additional help, you might have to generate all those scenarios by hand still. So we were very intrigued, and we thought, well, could we ask ChatGPT to help us generate some interesting negative test cases or some interesting security, API security scenarios that would help us go beyond what we could already do with captured traffic. So I'm just going to go through one example here. With some iteration, we came, with this prompt. Basically, we're using an example banking application. So we said, hey, we're working on a banking application. Please give us some positive and negative test scenarios. We expect them to be multi-step scenarios. So we want ChatGPT to string together some API calls. Consider what values might need to be passed to the API calls or passed between the different steps. And we gave it a format. So again, like the unit test case, we gave it an example. Please return it in this general format. And then what we did is our banking application has an open API document. So we just simply highlighted all the text that's on the page, right, from the open API document and included that in the prompt. And you just see the top of that here. So we gave it this prompt with the open API information and asked it to generate scenarios. And it generated, in this case, it generated one positive scenario and one negative scenario. So let's just briefly look at the negative scenario. You'll see that it tells us we should initialize our database, tells us we should create an account and gives us an initial balance with bad value, and says what it's doing, right? It's trying to create an account with a negative initial balance. So this would be a negative test case. Step 3 says, now when you try to get that account, it shouldn't actually exist because there should have been an error. So it's telling us, right, like, here's a case you should test and here's the behavior of the API. And then it does something similar with deposit, tries to deposit a negative amount and tells you you should get an error. And if you check the account again, the account doesn't exist, you should still get an error. And so on. So, and it goes through, I think, 4 or 5 different cases here of negative cases that we should test. These are all interesting. You'll notice it kind of made some, in this case, because we didn't give it more specific information about the API, right? What the open API has in that, just in the text on the page, didn't include a lot of information about the payloads. And so it did a lot of guessing about what values, kind of the parameter names. So this is something that we are still experimenting with. How can we refine the prompts and give it more information? Like maybe for each API, we could prompt it with additional information, like example request payloads and example response payloads, for instance. We're anticipating that with additional information like that, we could actually get it to give us even better values that better match what the service expects in the format of each REST API. But nevertheless, this is still very interesting. It shows that ChatGPT does have the power to generate some interesting cases. So we just have to figure out, how do we refine that so we can incorporate that into our scenarios that we generate with SOA test. Then the next thing we did is said, okay, well, we have this positive test scenario. I didn't go through it, but they had a nice positive scenario. We want to test that API for IDOR, which stands for Indirect Object Reference. So an indirect object reference vulnerability in a REST API is one where you might have a user that logs in, and then you have a second user that has their own account. They log in, but then they try to access information with some parameter value that's only valid in user one's account, right? So they're trying to access some, maybe the account or some kind of details about the account from a different user when they're logged in as their own user, but they're using some values that might have gotten returned to user one. So we just this is the prompt that we gave it based on this positive scenario. Please create us an test, and it actually generated a pretty nice test, subject to the limitations that it was still guessing because we didn't give it the payload information. But I'll just go through the first couple steps. Basically, it told us to create an account. So this is basically user one, and this valid value, so it should exist. Then you log in with a different user, and you then try to access the account with ID 1, which is user one's account, even though you're logged in as user 2. So this is, if this were to succeed, that would be what they call an indirect object reference vulnerability. So again, we see that ChatGPT is able to, it understands based on this training, it understands these different security vulnerabilities based on the information we can provide it as far as here's the open API, maybe we can provide it information about the payloads, maybe we can provide it information that we observed when we captured traffic, right? We provide it the right set of information, we think that we could get some really interesting scenarios out of it. So, again, we're imagining the future. What if in SOA tests, in addition to giving a user a really nice set of API scenarios just based on traffic, what if we can then enhance those with negative test cases that have real values, that exercise the API in the right way, with the proper assertions that validate that it behaves the right way? Or the same for security scenarios. Can we generate some scenarios that test different API for different API security issues, and again, give the user some API scenarios that might be hard to generate on their own. So again, we're really excited. We're actively researching how we can apply sort of the combination of what Parasoft already does well with API testing, with the power of what the generative AI can give us to create something that's even better.
Yeah, we strongly believe that this is a great opportunity for us to, from one perspective, enhance our offerings and use advantage of generative models, but at the same time address some of the concerns which comes with direct usage of those models, because we will basically combine it with our existing technology to deliver better results. I mean, if you look at the pyramid through all the layers, obviously, we didn't talk today about web UI testing. We have Selenium, our dedicated product for UI, which built on top of Selenium framework, which has self-healing capabilities. We just don't have time to cover today. We have this smart test execution technology, which consists of two components. It's test impact analysis and requirements impact analysis. Basically allows to optimize executions of your test, and it's applicable to optimization of your unit test or API functional test or UI test, or even manual test, which gives our customers the ability to save a lot of time and get faster feedback, because you run only those tests which are actually impacted by changes. We believe that generative AI can help us to even optimize those practices in the future as well, just outside of scope of today's discussion. To learn more about our current AI technology, what we're doing and how we're using inside the tools, feel free to download this white paper, use this code,